Hello students, welcome back. Today we are going to explore one of the most important tools in integration, the method of substitution for evaluating definite integrals. Think about it, sometimes when you try to integrate directly, the function looks impossible to handle. But with a clever change of variable, suddenly the problem becomes simple and solvable. That's the beauty of substitution. Our aim is to understand how definite integrals can be solved using substitution, step by step. To evaluate integral from a to b of f of x dx by substitution, we follow 4 steps. Step 1. Consider the integral without limits and substitute y equals f of x or x equals g of y to reduce the form. Step 2. Integrate the new integrand with respect to the new variable without writing any constant of integration. Step 3. Resubstitute back into the original variable. Step 4. Apply the given limits and find the difference of values at the upper and lower limits. This sequence ensures that substitution transforms a difficult problem into a standard one. Now, let us put the idea into a formula. Suppose we substitute x equals g of t. Then dx equals g dash of t dt. When x equals a, the lower limit becomes t equals g inverse of a. When x equals b, the upper limit becomes t equals g inverse of b. Therefore, the formula is integral from a to b f of x dx equals integral from g inverse of a to g inverse of b of f of g of t multiplied by g dash of t dt. Notice that substitution not only changes the integrand, but also the limits. Forgetting to change limits is one of the most common mistakes students make. Let's solve an example together. Evaluate integral from 0 to 1 of 2x divided by 1 plus x squared dx. Step 1. Put t equals 1 plus x squared. Then dt equals 2x dx. Step 2. When x equals 0, t equals 1. When x equals 1, t equals 2. So the integral becomes integral from 1 to 2 of 1 divided by t dt. That equals log of t from 1 to 2, which is log of 2 minus log of 1, and since log 1 equals 0, the answer is log 2. A difficult-looking rational function became a simple logarithm with just one substitution. Now let's move to a trigonometric example. Evaluate integral from 0 to pi by 2 of sin squared x dx. Step 1. Use the identity sin squared x equals 1 minus cos 2x divided by 2. So the integral becomes 1/2 times integral from 0 to pi by 2 of 1 minus cos 2x dx. Step 2. Integrate. That is 1/2 times bracket x minus 1/2 sin 2x bracket evaluated from 0 to pi by 2. Step 3. Substitute the limits. At x equals pi by 2, the value is pi by 2 minus 0. At x equals 0, the value is 0. So the answer is pi by 4. This example shows how substitution and identities go hand in hand to simplify trigonometric integrals. Now, where is substitution most useful? First, in rational functions like the one we saw, which reduce to logarithmic forms. Second, in trigonometric integrals, where identities and substitutions simplify powers or products. Third, in exponential and inverse functions, which become manageable after changing variables. And beyond exams, substitution is used in physics, engineering, and probability whenever we need to transform a problem into a solvable form. So let's summarize today's discussion. The method of substitution is one of the most powerful techniques for evaluating definite integrals. The steps are clear: substitute, integrate, resubstitute, apply limits. The general formula is integral from a to b f of x dx equals integral from g inverse of a to g inverse of b of f of g of t times g dash of t dt. And remember, always change both the integrand and the limits consistently. And that's the foundation of evaluating definite integrals by substitution. In the next video, we will explore how to apply these techniques to even more challenging integrals.